CS 3351 Digital Principles and Computer Organization. The topic is Introduction to Logic Circuits and K-Map, presented by Devi Visalakshi, Assistant Professor of CSE Department, Rohini College of Engineering and Technology. So first we are going to see about what is the meaning for logic circuits. The logic circuits for digital systems may be either combinational or sequential circuits. First we are going to see about combinational circuit. Combinational circuit consists of logic gates whose output at any time is determined from the present combination of inputs. The logic gate is the most basic building block of the logical combinational logic. The logical functions performed by a combinational circuit is fully defined by a set of Boolean expression. Next we are going to see about the sequential logic circuit. It comprises both logic gates and the state of storage elements such as flip-flops. As a consequence, the output of a sequential circuit depends not only on present value of inputs but also on the past state of inputs. Next we are going to see about the Karnaugh map. Karnaugh map is otherwise known as the K-map. The K-map is a systematic way of simplifying Boolean expressions. With the help of the K-map method, we can find the simplest POS and SOP expression, which is known as the minimum expression. The K-map provides a cookbook for simplification. There are the following steps used to solve the expressions using K-map. First, we have to find K-map as per the number of variables. Second, the maximum as well as min term in the following expressions we have to find. Third one, fill cells of K-map for SOP with respect to the min terms. Fill cells of the block of POS with 0 respective to the max terms. Next, we have to create rectangular groups that contains total number in the power of 2, like that is 2, 4, 8. Like this we have to try to form the elements in a one group. With the help of these groups, we find the product terms and sum them up for the SOP form. So now we have to see about what is the two variable K-map, how we have to frame that. So there is a total number of 4 variables in a 2 variable K-map. There are 2 variables in the 2 variable K-map. The following figure shows the structure of the 2 variable K-map. So it may be in the rectangle form or otherwise it will be in the square form. This is the way we have to represent the 2 variable K-map. Next one is the 3 variable K-map. The 3 variable K-map, it is represented as an array of 8 cells. In this case we use A, B, C for the variables. We can use any letter for the name of the variables. The binary values of variables A and B are along with the left side and the values of C are across the top. The value of the given cell or the binary values of A and B left side on the same row combined with the value of C at the top in the same column. For example, the cell is upper left corner has a binary value 000 and the cell in the lower right corner has binary value 101. This is the figure we have to describe the 3 variable K-map representation. Next one is the 4 variable K-map representation. The 4 variable K-map is represented as an array of 16 cells. Binary values of A and B are along the left side and the values of C and D are across the top. The value of the given cell is the binary values of A and B in the left side, same row combined with the binary value C and D at the top of the same column. For example, the cell in the upper right corner has a binary value 0010 and the cell in the lower corner has binary value of 1010. So this is the way we have to represent the 4 variable K-map. So next we have to see about the analysis of design procedure. First we have to discuss about analysis procedure. Analysis of a combination circuit determines its functionality, which is the logical function that the circuit implements, which includes logic diagram, set of Boolean values, a truth table and an explanation about the circuit explanation. Design procedures. The combination circuit can be designed by the following steps of design procedure. First is the problem is stated. The second one, identify the input and output variables. Third one, the input and output variables are assigned letter symbols. Fourth one is construction of a truth table to meet input output requirements. Fifth one is writing Boolean expressions for various output variables in terms of input variables. Sixth one, the simplified Boolean expression is obtained by any method of minimization, algebra method, K-map method or tabulation method. A logic diagram is realized from the simplified Boolean expression using logic gate. So these are the procedures we have to do for the design procedures. A practical design method has to consider the following constraints. Minimum number of gates should be there, minimum number of input to a gate, minimum propagation time of the signal through the circuit, minimum number of interconnections, limitations of the driving capabilities of each gate.